Good morning, students. In our previous class, we have discussed up to interference of light introduction, right? So today we will discuss about the conditions of interference of light and interference light of division of wavelength. Okay. So what is interference and interference of light. Now we have to discuss about the principle of superposition. So what is principle of superposition? Before that, we have to know about the types of interference. You already know that there are the two types of interferences: constructive interference and destructive interference. In that constructive interference, it is all based on the crest and trough and trough. In destructive interference, it is only about the crest trough and trough. These are the waves which is traveling from the light or any other sources. Okay, so principle of superposition is states that the resultant of the displacement of a particle which is acting upon the medium, two or more waves simultaneously is called algebraic sum. So we are discussing with two waves. The two waves are traveling at same time and same position and same distant time. It is going on. It will be like constructive interferences. For example, if we take a constructive interferences, then the displacement of the two waves or any two particles medium which is acted upon that, then we call it as a algebraic sum. And the particle of a same particle is individual values. By the way, these two waves are algebraic sum of displacement, but it has a same individual waves with a same particle in absence of others. Okay, this is called principle of superposition. Suppose due to single wave trying to the displacement of particle at a certain point at any instant, y1 is a given direction. If we take the wave is going on in a y1 and y2. y1 is the one wave and second one is the y2. The both the displacements and same as the same time and same displacement. According to that, if the first one is absent, then second one is at the present wave which is going on. If the second one is absent and the first one is present, the wave which is going on, the two waves as resultant displacement, we call it as a superposition. According to the principle of superposition, we call it the displacement of a particle due to two waves acting together. We expressed as R is equals to y1 plus y2. Okay, so the resultant displacement will be known as y1 plus y2. If the two displacements are in the opposite direction, then it is called R is equals to y1 minus y2. If the both are traveling in a one direction, then we call R is equals to y1 plus y2. Here R is called resultant displacement and y1 is the one wave and y2 is the another wave which is traveling in that interference of the light. So if you observe this picture, then you can understand very easily. This is the resultant displacement. In this picture you can see in the first one the wave is traveling like crest and trough. In the second picture it is on only axis. So in the first picture you can see the constructive interference. In that constructive interference, the waves are traveling in the one directions. Or if the second picture, the waves are traveling in a different, so it means opposite directions, then we get this resultant. This is the resultant displacement of the principle of superposition. If the two waves are acting together, this is the first picture, and if the waves are traveling in opposite direction, this is the second picture. So up to here the interference of light and the introduction of interference completed. So now in wave optics unit 1.1, the topics are conditions of interference of light. In this you'll learn the conditions of interference of light. Interference is which is nothing but the if one wave is traveling in the own direction, the any other wave which is disturbing the first wave, then we call it as a interference. So in these conditions of interference of light, there are some conditions for the interference of light. Those are, to obtain the permanent interference pattern, the conditions are classified into three parts. So these conditions are classified into three parts. So then we can decide it as a interference, conditions of interference of light. So first one is conditions for the sustained interference, second one is conditions for the observation of the fringes, and third one is conditions for the good constant between maxima and minima. So in our previous class we have discussed about the maxima and minima. What is maxima and what is minima? The top level of the crust, the crust is called maxima, and the bottom level of the trough is called minima. So it has to be good constant between the maxima and minima, then only we'll get the wave which is traveling like a wave. If it is not traveling like that, then it will be like a straight line, like equilibrium axis. So second one is conditions for the observation of fringes. Another condition is observation of fringes. After the wave is traveling, the resultant displacement will be like fringes, like white fringe or dark fringe. In that fringes also we can decide is it interference of light or not. Okay, and second and first one is in conditions for the sustained interference. It has some conditions which is the wave is should be sustained or not. Okay, these are all the conditions of the interference of light. Next one is conditions for the sustained interference. It has some, if we take it as a coherent sources, then the source should be like this. If you observe this picture, then you can understand very clearly. In that they have two options. First one is A. In these conditions for the sustained interference, we can set it as the source should be coherent. And next one is the two sources must be emit continuous waves of the same wavelength and the time period. It means that sources which is traveling like a wave, it should be emit continuously and should be same wavelength with a time period. Okay, the wave is traveling in a same wavelength, then it should have the time period. It should be continuously emitted that sources. This is the second condition. So in the first condition, they should vibrate in the same phase. In order to obtain stationary interference pattern, the resultant intensity at any point should be constant with time. It means if we take an example of a sound waves, if we are speaking, then the waves are traveling with a vibration to someone ear or anything. Okay, like that it is traveling. So they should be vibrating in same phase. If you are talking, then the waves are vibrating with your mouth to someone ear, then the source should be coherent. In order to obtain the stationary interference pattern, the resultant intensity point should be constant with time. So the resultant point should be constant with the time. The resultant intensity is called I is equals to a1 square plus a2 square plus 2a1 a2 cos delta. So it is observed that I will be constant provided delta remains constant. The total phase differences between the delta consists of the two factors delta 1 and delta 2. It means if the person is delta 1 and the another person is delta 2, if we are speaking, then our waves are traveling in vibrational waves to someone here, that is delta 2. Then the distance of wavelength or traveling in that time it is constant. So we call it as delta is equals to delta 1 plus delta 2, where delta 1 is initial phase difference between the two sources and delta 2 is the final phase to the point. Okay, this is the source should be coherent. Due to the path differences, the two waves are traveling in the different particular points. So if the person is one side and another person is another side, it takes some wavelength to travel the one wave from initial point to that particular point. The point remains constant until that wave travel from the initial. Okay, so delta 1 is traveling up to delta 2 until the delta 2 should be remains constant. The delta will be remains constant, delta 1 remains should be constant here. Okay, so next one is the two sources must be emit continuous waves of the same wavelength and time period. If the source do not emit light at the same period, it means the sun which is emitted the light to us, it is showing only at one period. It is not showing, it is not emitting in another period. Then the source should be intensively at the point. It has some maximum value and the minimum value, hence the interference will not be sustained. In that time the interference will not be sustained. This is the another condition. The sources which is emitting continuously waves, but there is a another time period, then we call it as a interference will not be sustained. Okay, so our next one is conditions for the observation. In expression of fringes, I have told you that there are the fringes, two fringes, dark fringe and bright fringe. In the fringes, the width of the fringe is beta is equals to lambda d by 2d. In lambda d by 2d, it means lambda is a wavelength, you already know that. D is the another one distance travel and 2d is the other hand of the fringes. The conditions of observation: if you observe the bright fringe or dark fringe, then the width of the fringes should be beta is equals to lambda d by 2d. Here the separation between the two sources, if S1 is the one source and S2 is the another source, both are saying at the same place to someone's if two persons are saying in one position, then the waves are traveling in one direction. There should be some wavelength that is called lambda here. Okay, the fringes with lambda d by 2d is large and the fringes are separately visible. On the other hand, 2d is the large fringe with which will be travel some distance small and the limited resolving power of the eye. Here if you observe the diagram, S1 is the one source and S2 is the another source which is traveling which is in the same place and which is saying from the same place. P is the position or resultant. And if you observe the S1 to P and S2 to P, there is some lambda wavelength, and here the 2d is the angle and 2d sin theta is the second angle of the source. Okay, so the distance d between the two sources at the screen should be large. The background should be dark. In the distance between the two sources, the screen should be larger and the second background is dark. Then we can get the dark fringe and the back one is the white fringes. It means bright fringes. So if you see this diagram, then you can understand very quickly. If it is 2d is large, then the fringes will be like this. If 2d is small, then the fringes will be like this. Okay, here 2d means S1 to S2. The angle which is made between the S1 to S2, then the fringes should be 2d is large. If the fringes are the distance between the S1 to S2 dash, then it is created some angle 2d dash sin theta, then the fringes should be the fringes distance should be small like this. Okay, this is the second condition. In the third condition, what is the third condition? Conditions for the good constraint. So the amplitude of interfacing wavelength should be equal and nearly equal. I have told you yesterday that they are the different amplitude which is based on the wave traveling in that direction. So the wave can be 0 to 1.1 or 0 to 1.2. They are the different amplitudes. In case of two interfacing waves of amplitude a1 and a2, the instantaneous of maxima or minima is a1 plus a2 whole square and a1 minus a2 whole square respectively. If the two amplitudes are equal, the minimum intensity would be 0, and there will be good constant between the maxima and minima. Okay, so the waves are traveling in the maxima or minima. There is no not equal amplitudes. It has only the two equal amplitudes. Then it should be intensity should be 0 with a good constant. So we will get the equation a1 plus a2 whole square or a1 minus a2 whole square. In this, maxima is a1 plus a2 whole square and minima is a1 minus a2 whole square respectively. The source must be narrow, that is, they must be extremely small. If the source are not narrow, the interference between the waves from the different parts of the some sources will be take place and constant will be poor. It means the source is not narrow. The interference between the waves different parts and different sources. The interference of a source will be narrow, then they must be extremely small. Okay, so next one is the source should be monochromatic. You already know what is monochromatic is nothing but the light which has a white color source which is showing emitting the white color source is known as monochromatic light. Then it separated colors. If you place any mirror or if you place any prism, then it separated the 7 colors like VIBGYOR. If the source is a white light, then it travels in a prism and it shows 7 colors. That is called monochromatic light. Instead of that monochromatic light source, white source is used, then the separated color will produce it in the own interference with the own spacing, then net effect will be white light. Without the monochromatic light also we'll get the different colors by using the own spacing and the net effect. This is called the source should be monochromatic. That's why the source should be monochromatic light. Okay, these are all the conditions for the interference of light. Up to here, unit 1 topic completed. In our next class we will discuss the another topics. Okay, thank you.